Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and nature topics. Today we're going to cover N6 strength of materials, and the topic of this discussion is shear legs. Let's get straight into it. Okay, first off, what is a shear leg? A shear leg is a type of crane. Now it looks something like this. You have your shear legs and you have a backstay. Now it's connected like this. The backstay is on a track and the shear legs are anchored. So what happens is when you want to get your load and connect your load up, the backstay moves forward and the shear legs move like this. You pick up your load and then the backstay moves back like so. Okay, now that you've got a simple and basic understanding of what we're doing, let's get straight into the problem. Okay, our problem states the legs of a shear leg are each 14 meters long and the feet are 10 meters apart. The backstay is 20 meters long and a load of 30 kilonewtons is suspended from the apex and has a 4-meter overhang. Determine graphically the forces in the legs and backstay. For reference, this is what we're going to be working with. Okay. Here is our shear legs and here is our force. This is 30 kilonewtons. This is 14 meters. That is 20 meters. And from here to here is 4 meters. That's the overhang. That is how far the load has come across. Now next, we're going to do a front view to get the rest of this. 14, 14, and 10 meters. Okay. So now, what we're going to do now is we're going to do an appropriate scale. My scale is going to be a 2-to-1 scale, so a double scale, and it's suggested for your books you do a half scale. So that is all your measurements so that you can actually fit them in your book. Now let's write down our values. So our scale is 2-to-1. Our scale is 2-to-1, so 14 equals 28, 20 equals 40, 10 equals 20, centimeters, and 4 equals 8 centimeters. Right. Force scale. Mine will be 1:2. My scale will be a 1:2 scale. Because now 13 kilonewtons equals 15 centimeters. Okay, let's see if we've got everything. We've got 14, we've got 10, we've got 20, I've got 4. Perfect. Now we are ready. Now we are ready to draw our shear legs graphically. They want you to solve this. The only way you can solve these problems is graphically. So, first things first, draw your datum line. Now you want your datum line near the middle of the page, but still near the bottom. This is so that you have enough. This is so you have enough space to work. This is so that you have enough space to work. But still, this is so you have enough space to work, but still have enough space to have your next drawing at the top. Right. So first things first, we have to draw our AB line. So that's perpendicular to our datum line. So now my one is going to be 20. So I've got to do 10. A, and that's B. Okay. Now what we need to do is take our pair of compasses. What we do next is then measure from A and B to our datum line 14 centimeters. Mine will be 28 because I'm double. Right. Now we join the two lines. Now we join A. Now this point is O. Now this point is O. So now we join A with O and B with O. Right. Now, what we're going to do next is we are going to draw our second datum line, which is a little bit higher than the first. The prescribed way is to do 1.5 centimeters above your highest point. Okay? I'm just going to do a ruler width. Right. Now what we have to do is project A and B up. We've got to project A and B, AB up, and O up. We've got to project them. So let's project. Let's project. Okay, now that we've projected these lines, what we need to do next, once we've projected these lines, is take our pair of compasses again and measure from A to there. And we draw an arc going up. Okay, once we have the arc, then what we need to do is measure our overhang. So we measure from A, and we measure our overhang. That's my overhang. Okay. Okay. Now, we're lucky, because an overhang means that we know exactly where our load line is going to be. And because we know exactly where our load line is going to be, we also know exactly where our legs will join up. So, for the purposes of this, there's the leg. Now we're going to measure the backstay. Now this backstay is 20 meters long, so that is a full 40 for me. Measure from there and draw a line. That is how long your backstay is. Right. Now this point is C. This point is O1. This is A1. That doesn't have a point. And this is O. So CO. CO must have a point. Okay. Next thing to do is now we need to do our load line. So my load is a 1:2 scale. So mine is 30 kilonewtons, it will equal 15 centimeters. Yours will be slightly different, but always try and do okay. Now I've got a load. Now I have a load line. Okay. Next, what we're going to do is take the angle of this line, and we're going to put it here. Take this line and put it all the way up to here, and then join that together. Okay, I'll show you. I'll explain what I'm doing. Okay. Now this is the easiest way I found to do this. You can do it with a protractor and everything, but a protractor just takes a long time. Okay. That's one line down. All right. Now what we do is we lengthen our backstay line. We lengthen our backstay slightly. Right. Always do a dotted line because that's not the real length of your backstay. All right. Now what we have to do to get the point, now we have to get this distance here with our compasses so that we're able to get the distance from there to wherever the point is over here. So let's draw this line here. Right, and I almost forgot. C has to come down. C also has to come down. This is all for extra marks. You get marks where you can, all the time. And that is C. That's C1, and this is C. Okay. Now, as we know, now I've got to get this line down to here. Just make sure that it's correct. Right. So now we have this point here. Now what we need to do is measure from here to that line, and we draw a line from there to here. Then measure from there, measure up, and draw a line there. Okay, that's what we're going to do now. Alright, there's our two lines. Now we have to convert every measurement into kilonewtons. So let's label, let's carry on labeling. This is N, this is M, and you can label this L for load. Right, this is T and that is S. Right, so now we measure from the end of the backstay to your point over here, -8. -8, and since it is half, I've got to multiply by 2. So -8 centimeters multiplied by 2 equals 16 kilonewtons. Right, this is equal to, and this is equal to OM. Right, OT is equal to I have here 12. I have here 12. So 12 times 2 equals 24 kilonewtons. OS will be the same. Let's just make sure. Perfect. That is perfectly accurate. And that is how you do a shear leg crane. Just give you a moment to take this down. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you would like me to cover in upcoming videos. Be at peace, be kind to each other, and always remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.